In this video, we are going to discuss why we can multiply straight across in fraction multiplication instead of needing a common denominator like in addition and subtraction. This video is meant to follow two previous videos titled Fraction of a Fraction and Why Does Of Mean Multiply? If you have not already watched those videos, you should refer back to them first because this video assumes that you are already familiar with the material presented in those videos. If you have watched them and you're ready, let's get started with our first example. Here I am asked to solve 1/3 multiplied by 4/5. I interpret this to mean 1/3 of 4/5 of 1. With this in mind, I can start by representing 4/5 like this in orange. Then I split the 4/5 into thirds by slicing horizontally so that the thirds go across like this, with 1/3 here, 1/3 here, and 1/3 here. With this, I can see that 1/3 of the 4/5 would be the amount across the top here. But in order to determine what that is in relation to the entire whole, I need to extend the lines all the way out, and you can see here that the entire whole is now split into 15ths. When I do this, this is the 3 times 5 equals 15 in the denominators, because splitting the fifths into thirds triples the number of equal-sized parts the whole is partitioned into from 5 to 15. The pieces are now smaller than they were before because the whole is partitioned into 3 times as many parts. Now that the 4/5 has been broken into thirds, I'm going to shade in one of those thirds pink to show 1/3 of the 4/5 like I talked about earlier. Notice here that the number of shaded parts has remained the same. There were 4 shaded parts here in orange for 4/5, and now there are 4 shaded parts in pink, but the pieces are 1/3 the size that they were before. This is the 1 times 4 in the numerators, and taking that all into account, you can count up the pink parts here and see that 1/3 of 4/5 is 4/15 of the entire whole. Our next question is 2/3 times 4/5. Thinking of this as 2/3 of 4/5, I began exactly like I did in the previous problem by creating 4/5 of the whole, and then splitting that amount into thirds like this. I then extend the lines all the way out so that I can see what my amounts are in relation to the entire whole, and this partitions the whole into 15ths. When I do that, this is the 3 times 5 in the denominators, because splitting the fifths into thirds triples the number of equal-sized parts the whole is partitioned into from 5 large parts to 15 smaller parts. Now in this example, though, I need to find 2/3 instead of 1/3, so I shade in 2 of the thirds, representing 2/3 of the 4/5. When this happens, the number of shaded parts is doubled. It goes from 4 shaded parts to 8 shaded parts, and that is the 2 times 4 in the numerators. Altogether, 2/3 of 4/5 is 8/15. For our final example, it asks 3/3 times 4/5. Thinking of this as 3/3 of 4/5, I start like the other examples by creating 4/5 of the whole. Then I split that amount into thirds horizontally, like that, and extend the lines all the way out so that I can see what my amounts are in relation to the whole, and this partitions the whole into 15ths. When this is done, this is the 3 times 5, because splitting the fifths into thirds triples the number of equal-sized pieces the whole is partitioned into from 5 to 15. From here, I need to find 3/3 of 4/5, so I shade in all of the thirds like this, and this triples the number of shaded parts from 4 to 12, which is the 3 times 4 in the numerators. You'll notice here that the entire 4/5 has been shaded over, and that is because the numerator and the denominator were both tripled. When the denominator was tripled, that split the whole into 3 times as many parts, from 5 large parts into 15 smaller parts. When the numerator was tripled, that increased the number of parts that were shaded in from 4 to 12, but the parts are 1/3 the size that they were before. Since we are multiplying by 3 in both cases, the shaded area is the same for 4/5 as it is for 12/15. So 3/3 of 4/5 is 12/15. To wrap all of this up, let's return to the first example, 1/3 multiplied by 4/5. We discussed that this is interpreted as 1/3 of 4/5 of 1, and therefore could be modeled in a way that illustrates the connection to the procedure of multiplying straight across. We start with 4/5, like this, and then we split it into thirds, and then we extend the lines all the way out, which causes the whole to be partitioned into 3 times as many pieces, which is the same as saying we multiplied the amount of pieces in the whole by 3. From there, we needed to find 1/3 of the 4/5, so we shaded in 1/3 of the amount, which resulted in 4 shaded parts. This was the same as multiplying the shaded parts by 1, but now the pieces are 1/3 the size. So 1/3 of 4/5 is 4/15. With all of this, you may be wondering why it is even worth the time to understand this procedure of multiplying straight across with fractions when the procedure works and gives the correct answer without this knowledge. Teaching students to do just the procedure without conceptual understanding is not enough in the current educational context. In the standards today, students are expected to have conceptual understanding of fraction operations, and so as a teacher, you need to understand how these operations work and be able to teach them effectively to your students. In addition to meeting the expectations set forth by the standards, it is empowering and exciting for students to understand what they are doing and to know that these procedures, like multiplying straight across, are not just arbitrary rules. So with that all in mind, I hope this video and the related videos that come before it are helpful to you as you grow to understand and teach fraction multiplication.